Hi, this is Wendy Owens presenting 3 maps for Activity 4, Week 2. I will be showing 3 maps representing different scales, coordinates, and projection types. The first 2 maps are from the internet and are static maps published for different purposes. The last map is a map that I created by using the U.S. Department of Agriculture Natural Resources Conservation Service Web Soil Survey Interactive Mapping Tool. This map is from the scientific paper by Fox and McGulloch 2019, titled Predicting Hydrologic Disturbance of Streams Using Species Occurrence Data. The authors looked at spatial patterns of hydrologic disturbance by looking at species occurrences in the watershed. This map that was created uses a large scale with a graphic bar shown in the lower right-hand corner. The projection used is conformal or Mercator. The coordinate system is latitude, longitude using degrees as you noted on the left side of the map. The next map I chose is on earthquake vulnerability in Washington State. I chose it because it uses the state planar coordinate system. This map was obtained from a poster presented by Alexander Kirkpatch, 2017, called Places to Stay Away From During the Next 50 Years. Earthquake Vulnerability Analysis in Washington State. As you can see, the author of the map uses colors to indicate areas within Washington State which are the most vulnerable to an earthquake or tsunami. The map is a small scale, 1 inch equals 100 miles, shown as a graphic bar. The projection is a Lambert conformal conic, and the coordinate system is the NAD 1983 HARN state plane. The last map I chose was to create a map by using the mapping tool called the Web Soil Survey from the USDA Natural Resource Conservation Service. Previous to the year 2000, many of the soil surveys could only be obtained by the county in question. It was a very cumbersome process, but many individuals who were interested in farming, construction, adding in septic tanks needed these soil surveys. The drawback was many of these soil surveys were out of date. They would be up to date every 10 years, 20 years, and in some cases 30 to 40 years from my own experience. Since the early 2000s, USDA and NRCS have digitized the soil survey books and requested county states to submit up-to-date surveys to this website. All this data is now accessible online via the USDA NRCS website using the Web Soil Survey tool. Several types of maps and scales are used based on the need of the investigator in this tool. This is the interactive map, and I will demonstrate how to use it and show a completed map portraying all the details we have learned this week about maps. In order to use this soil map tool, you would have to create an area of interest. On this landing page, you can see on the left-hand side, there's quick navigation tools. You can choose an address, you can choose the state or county, and I decided to start with choosing the state and the county. I chose Monroe County, and as you can see, it's still pretty large. I can't focus in on an area to show me exactly what the soil types are. And then you can see that the representative fraction is 1 to 173,000. Therefore, I decided to close in on the area of RIT. I did this by adding the address to the address under the quick navigation, and this brought me to the RIT campus. But in order to get an actual picture of what type of soils there were, I still had to create an area of interest. There are little polygons that can be used to create the area of interest. And after I created my area of interest, I exported it into a PDF form, and the report that resulted was a map with all the soil types, as well as the details about each type of soil found within my area of interest. This is the final map. As you can see, it has a map scale of 1 to 13,900. It is using a web Mercator projection, and the coordinate system is UTM. Thank you for listening to my presentation, and if you want more information, please feel free to email me or contact me, and these are my references that can also be used if you would like to learn more. Thank you.